All right, so here we're given the function f of x equals 8 minus 0.5x squared, and we want to approximate the area under f of x from 1 to 3. So first things first, graph the function over the interval 0 to 4. Then draw left and right hand rectangles for the interval 1 to 3 with n is equal to 4. All right, so let's go to a calculator and see what that looks like. So if we go to our calculator, what do we have? Let's get rid of that. And so we had 8 minus 0.5x squared. And we want to go from 0, let's go to 5. It's a little longer than what we need to go to. And let's just go from 0 up to, I don't know what it needs to go to, 15. And let's go by 5. That's fine. All right, so that's what our graph looks like. And so we'll draw that by hand, and then we're going to be doing from 1 to 3. So 1, 2, 3, here's 4, and then that was 5. And so we'll be drawing rectangles in here, again, by hand, but that's what we're going to be doing. So let's go back to our thing, and let's draw something to that effect here. So we're going to have, and it's going to kind of do something like that. And that was at, what was that one? That was at 4, 0. And if we plug in 0 here, we get 8. So that's going to be at the point 0, 8. And then we have, so halfway, that would be a 2, and then half of that would be 1, and then that would be 3. And so we're going to draw right triangle or rectangles here. So we'll have to come up, and then we'll come up again. We'll keep going because we know we're going to have to go up higher. And we'll come up again. And we'll just make them higher, but we can erase what we need to do there. All right, so this is 1, 2, 3, and that's 4. All right, so we'll make a left point triangle, and that comes basically, what are we doing here? It's going to come over. Okay, it's not going to come over, but it will come over. It's going to come over, and we're going to be about like that. So our left one now is overestimating instead of underestimating. Now our right one is going to come from here, and it's going to go that direction. That's probably going to disappear now. And then we'll come back here, and we'll go over, go that way. Yep, I knew it. And this one's going to come over and go that way. And so now we have, let's see, 1, 2, how many are we having? Over and then draw left and right triangle for one is 4. So that's 2 of them. Now we need 2 more. So that means we have to go in between here and in between here. And so again, we'll go across, over. Actually, this would be here instead. We went and didn't read the directions is what we didn't do. So let's erase all of this here. We just should read directions to start with. I forgot it was 4. All right, 1, 2, 3, 4. All right, so we're coming over and then down. And then that's going to be our right triangle. The top one's left. Then we'll come over and down and then over. Then we'll come over and down and over. We'll come over and down and then we'll come over. So now we've got 1, 2, 3, 4. So now we've got our n equals 4 instead of n equals 2. And we're going from 1 to 3. We've got our left and we've got our right. And so now what we need to do is we need to find that point, that point, that point, that point, and that point. Okay. And so we're going to go to our calculator and we're going to get those from there. And how we do that is we just do our second trace. We want a value and we need it at what? We need it at 1. And so what we're going to do is we're going to say, okay, well, at 1, we get 7.5. Okay. Now, what do we do? Now we do 1.5. So that's going to be halfway. That's going to be 6.875. All right, then we do 2. That's going to be 6. We go to 2.5. That's going to be 4.875. And then we do a 3, and that's going to be 3.5. So that should give us all of our points that we need. So that was, where did my pen go? There we go. That was 1 and 7.5. That was 1.5 and 6.875. This one was 2 and 6. This one was 2.5 and 4.875. And this one was 3 and 3.5. All right, so now we've got all our endpoints. All right, so now we have to calculate, it says L4, R4, and the error bounds. Okay, so we've graphed it. We've got all the left and right triangles. We've got the key points on that. So A is done. So B now. All right, L4. Okay, so what is our distance? Well, each one of these is a half. So our distance is 1/2 times. Now our first one is going to be 7.5. That's our height. Plus, and then we have a half again. And our distance on that one, it says, is 6.875. Plus 1/2 times our distance, which is 6, plus 1/2 times our distance there is 4.875. Okay, and so that one is going to be the last left bound. Okay, so that one we stop at. And so now what we do is we plug that in our calculator, and to save time, that's just 12.625. So that's L4. What about R4? Well, now, again, it's going to be a half, but now we're starting over here and going this direction. So now our distance, first one, is going to be 6.875 plus a half times, and then we go to 6 plus a half times 4.875 plus a half times what? 3 point, oops, half, 3.5. And again, to save time, that's 10.625. Now notice this one is over, this one's underestimating. And that's what we kind of saw when we went this direction. When we have a decreasing function, then we're overestimating on the left and we're underestimating on the right. Okay. Now ask for error. And so for that one, the error is going to be less than or equal to, and now we have what? F3 minus F1, and then times 3 minus 1 over. We had 4 different things. Well, that's going to be what? 3.5 minus 7.5 times, and 3 minus 1 is 2, divided by that, so it's a half. And 7 minus 3 is 4, half of 4, so this looks like it's going to be 2. Okay, so the error is going to be less than or equal to 2. Now, the last one, C, how large should n be? So now we have to solve for n, which is this value, for the approximate area of Ln or Rn to be within 0.5 of the true value. Okay, well, that's going to be C. We're going to have, well, if we want to have, again, everything else is the same except for that. We have the error is going to be less than or equal to what? Absolute value. And this absolute value is going to be a -4, but the absolute value, that's positive. So that's -4 times 2 over n, and that's less than or equal to 1/2. Now we just kind of multiply. So then we get what? We get 4 times that's 8 times 2 is 16. It is going to be greater than or equal to, well, actually less than or equal to, what am I writing there? Less than or equal to the n. Okay, so that means n has to be greater than or equal to 16. So anything greater than or equal to 16 will have an error that's going to be within 0.5 of the true value. So we have to have at least 16 subdivisions. So we've done 4, so we have to break those down, break those down, break those down, break those down to be able to get it to be within 0.5. All right, so that's what we have for that problem. So let's stop there. We'll come back for some more.